Paper 5054, October-November 2025, Question Paper 22. Question 1. Speed-time graph of a car. We have a speed-time graph. The height of the graph gives the speed, and the area under the graph is the distance traveled. Part 1. Speed at time 0. Read the height of the flat section at the start. The speed is 29 meters per second. Part 2. Distance during the reaction time, from 5.7 to 6.4 seconds. The speed stays constant, so use a rectangle. Distance equals speed times time. Time is 0.7 seconds, giving 20 meters. Part 3. Total distance from 0 to 11.2 seconds. Split the area into a rectangle plus a triangle for the braking section. The total distance is about 260 meters. Part B. A factor affecting only the braking distance. A wet or icy road, worn tires, or worn brakes reduces friction. Less friction means smaller deceleration and a longer braking distance. Paper 5054, October-November 2025, Question Paper 22. Question 2. Terminal velocity in a lake. Terminal velocity is the constant speed reached when drag balances weight, so the resultant force is 0. Part A. Why the container reaches terminal velocity. At first weight is greater than drag, so it accelerates. As speed rises, drag increases and the resultant force decreases. When drag equals weight, the resultant is 0 and the speed becomes constant. On a speed-time graph, the speed rises steeply at first, then levels off as it approaches terminal velocity. Part B. Part 1. Gravitational potential energy equals mgh. With mass 74 kilograms, g 9.8, and height 32 meters, the energy is 2.3 times 10 to the 4 joules. Part B. Part 2. Conservation of energy. Energy cannot be created or destroyed, it is only transferred from one store to another. Part B. Part 3. At terminal velocity, work is done against drag. Gravitational potential energy transfers to the internal thermal store of the water. Paper 5054, October-November 2025, Question Paper 22. Question 3. Momentum of a water jet. A water jet hits a wall at 24 meters per second. 7.5 times 10 to the minus 3 cubic meters flows in 1 second. Plan, find the mass in 1 second, then momentum P equals mv, then force equals change in momentum over time. Part 1. Mass of water in 1 second. Mass equals density times volume. 1000 times 7.5 times 10 to the minus 3 gives 7.5 kilograms. Part 2. Momentum in 1 second. Momentum equals mass times velocity. 7.5 times 24 gives 180 kilogram meters per second. Part B. Why the force is 180 newtons. The water stops, so the change in momentum is 180 in 1 second. Force equals change in momentum over time, 180 newtons. Part C. Force on the wall. By Newton's third law, the wall exerts a force on the water to stop it, and the water exerts an equal and opposite force on the wall. Part D. Double the speed and the force increases by a factor of 4. Twice the speed means twice the mass per second and twice the velocity, so 2 times 2 equals 4. Paper 5054, October-November 2025, Question Paper 22. Question 4. Heating and melting wax. This is a temperature-time graph for wax being heated. A sloped section means temperature is rising. A flat section means melting, energy breaks bonds instead of raising temperature. Part A. The melting temperature is 63 degrees Celsius, read from the horizontal section on the graph. Part B. Part 1. Energy gained from 0 to 220 seconds, while temperature is changing. Use E equals mc delta theta. With mass 0.040 kilograms, specific heat capacity 2100, and temperature rise 27 degrees, the energy is about 2300 joules. Part B. Part 2. In the solid, molecules gain kinetic energy and vibrate faster about their fixed positions. Part C. Energy is needed to melt the wax because it overcomes the forces between molecules. Temperature stays constant on the flat section while bonds break. Paper 5054, October-November 2025, Question Paper 22. Question 5. Electromagnetic spectrum and microwaves. Part A. Name the waves in boxes 3 and 6. Box 3 is ultraviolet, and box 6 is microwaves. The order runs gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio. Part B. Part 1. Wavelength of microwaves at 12 GHz. Use lambda equals c over f. 3 times 10 to the 8 divided by 1.2 times 10 to the 10 gives 0.025 meters. Part B. Part 2. Microwaves in satellite television. A microwave signal is sent up from Earth to the satellite, and the satellite transmits microwaves back down to the dish on Earth. Part C. Why a microwave oven switches off when opened. A safety interlock switch is wired in series with the source. When the door opens, the circuit breaks and microwaves stop, preventing burns from microwaves heating water in tissue. Paper 5054, October-November 2025, Question Paper 22. Question 6. Electric car circuit. Part A. The car motor is a DC motor, it needs current in one direction. A split-ring commutator keeps the coil turning the same way. Direct current flows one way, so the motor keeps spinning. Alternating current would reverse each half cycle and the motor would not work properly. Part B. Part 1. Charge equals current times time. With 41 amps for 120 seconds, the charge is 4.9 times 10 to the 3 coulombs. Part B. Part 2. Number of electrons equals charge divided by E. In 1 second the charge is 41 coulombs, giving about 2.6 times 10 to the 20 electrons, drifting toward the positive terminal opposite to conventional current. Part C. Electromotive force is the work done by the source per unit charge around the complete circuit. 92 cells in series give 340 volts. 85 batteries in parallel keep the same e.m.f but share the current. Paper 5054, October-November 2025, Question Paper 22. Question 7. Electric kettle and fuse. Part A. Part 1. Using P equals VI, the current is power divided by voltage. 2300 watts at 230 volts gives 10 amps. Part A. Part 2. Choose the 13-amp fuse, just above the 10-amp working current but below the 15-amp cable limit. Part B. Part 1. The fuse must be in the live wire so the supply is cut when it blows, and no part of the kettle stays live. Part B. Part 2. If an exposed live wire touches the metal case, a large current flows through the earth wire, melting the fuse and cutting off the supply. Part C. Cost equals energy in kilowatt-hours times price. 2.3 kilowatts for 34 hours is 78.2 kilowatt-hours. At 32 cents per kilowatt-hour, the cost is $25.02. Paper 5054, October-November 2025, Question Paper 22. Question 8. Isotopes of lithium. Part A. All lithium isotopes have the same number of protons and electrons, 3. They differ in the number of neutrons, so the nucleon number changes. Part B. Part 1. In the notation, Y is the proton number, 3, and X is the total nucleons, 3 protons plus 2 neutrons equals 5. Part B. Part 2. A +1 lithium ion has lost one outer electron, leaving only 2 electrons in the shells. Part C. Nuclear radiation can kill cells, cause cancer, mutations, or burns. Decay is random, you cannot predict which nucleus decays or when. It is also spontaneous, not affected by temperature or pressure. Paper 5054, October-November 2025, Question Paper 22. Question 9. The Sun's orbit in the Milky Way. Part A. Part 1. 1 light-year is about 9.5 times 10 to the 12 kilometers. 26,000 light-years gives a distance of about 2.5 times 10 to the 17 kilometers. Part A. Part 2. Orbital speed equals circumference over time. Convert radius to meters and period to seconds, giving about 2.1 times 10 to the 5 meters per second. Part B. Part 1. A massive star becomes a red supergiant when hydrogen fuel in the core runs out, the core contracts while the outer layers expand and cool. Part B. Part 2. The supergiant explodes as a supernova, and the remaining core collapses under gravity into a black hole. Part B. Part 3. The heaviest elements are formed when nuclei fuse during the supernova explosion.